Hello and welcome to Code Rash with Gaurav, where we break down AI into easy and consumable chunks. Today, we are talking about a burning topic these days. Why do most of the AI agents fail in production? And what can we do to not let that happen? So, confession time. About 2 years ago, I built what I thought was an incredible AI agent. It answered questions perfectly in my Jupyter notebook. The demo looked slick. I showed it to my team, and everyone was impressed. Then we deployed it to production. Within 24 hours, it crashed 3 times. Users got inconsistent responses. One edge case broke the entire flow. And the logs? Well, there were no logs. I spent an entire weekend debugging what I thought would be a smooth launch. Sounds familiar? In this video, let's tackle a burning question. Why do so many AI agents stay stuck in proof of concept mode and never reach real production? And how can developers build agents that actually deliver at scale? Today, we're diving into why most AI agents never make it past the proof of concept stage, and more importantly, I'm going to show you the exact 5-step framework for building agents that actually survive production. We'll look at real examples, and by the end, you'll know how to avoid the mistakes that keep 90% of AI agents stuck in demo hell. Let's get into it. Let us look at the most common mistakes generally AI agent developers do and why it fails in production. Let me show you what I mean. Here's a typical agent that looks great in a demo. This works fine when you're showing it to your team. But production doesn't care about demos. Production cares about what happens when your API rate limit hits. A user sends malformed input. You need to debug why it gave a wrong answer 3 days ago. You need to handle 1,000 concurrent users instead of 1. The difference between a toy and a production system comes down to 5 critical areas that we're going to deep dive into. And I'm going to show you exactly how to implement each one with real code. Step 1: Python Foundations. Alright, first things first. Before you even think about agents or LLMs, you need to nail the production Python fundamentals. This is where most people skip ahead and pay for it later. You need 3 core tools: Fast API, async programming, and Pydantic. Let me show you why each one matters. First up, Fast API. This is how your agent talks to the world. Check out this production-ready endpoint. We have a few imports and then instance of Fast API. We are defining a few types like the agent request and agent response. Agent request extends base model and adds a field called query with a minimum and maximum length specified. See what's happening here? Pydantic is automatically validating our inputs. If someone sends garbage data, it gets rejected before it even touches your agent logic. This prevents so many production bugs. Now, notice that async keyword? That's crucial. Let me show you why. In production, your agent is probably calling multiple APIs, hitting databases, waiting on responses. Async lets you do all of that in parallel instead of blocking. This is the difference between handling 10 requests per second and a 1000. A slow agent blocks on every API call and does things synchronously, while a fast agent can await for time-taking tasks and process multiple requests in parallel. If you skip these foundations, you'll be duct taping random functions together for months. Get this right, and everything else becomes easier. Okay, so your agent technically works now. Great, but production doesn't care about that. It cares about what happens when things don't work. This is where logging and testing come in, and I'm going to show you how to implement both properly. First, logging. This is your X-ray vision into production. When something breaks at 3 a.m., logs are the only thing standing between you and hours of guessing. Notice we're using structured logging with JSON. Here we have a logger class and utility methods, which we are using in our agent and logging success and error both. This means you can easily query your logs later. Show me all queries that took longer than 5 seconds or find all errors from the session. Now let's talk testing. Here's how you test an AI agent properly. We have tests for positive and negative cases with mocks for the external dependencies like LLM completion. These tests catch bugs before they hit production. Every time you change your agent, run these tests. If they pass, you can ship with confidence. Put both logging and testing in place now, or you'll spend double the time later debugging chaos. Trust me on this one. Step 3. RAG implementation. Alright, now we're getting to the good stuff. RAG, Retrieval Augmented Generation. This is what turns your agent from a chatbot that hallucinates into something to an agent that actually knows things. The basic idea. Instead of relying only on the LLM's training data, you give it access to a knowledge base it can search through in real time. Let me show you how to build this properly. It is very important for an agent to say that it doesn't know the answer rather than hallucinating and making up an answer. This is production-grade RAG. Notice a few key things. 1. We're using PostgreSQL with pgvector. You don't need a fancy vector database for most use cases. Postgres works great, and you probably already know it. 2. We're chunking and storing documents properly with metadata. This lets you filter and organize your knowledge base. 3. We're using cosine similarity to find relevant documents. This is way more reliable than keyword search. Here's the critical part most people miss: chunking strategy. If you chunk your documents wrong, your RAG will fail. Let me show it to you. Bad chunking splits randomly. Good chunking has semantic splits. Good chunking preserves meaning and context. This is the difference between RAG that works and RAG that fails silently. Step 4. Agent architecture. Okay, we're getting into the heavy stuff now. A real production agent isn't just a prompt. It's a complete system with state management, memory, error handling, and orchestration. Let me show you how to build this using LangGraph, which gives you a proper agent framework. We have agent state for better logging. We will use this to log every step of the workflow. We are using RAG. We have a limit on the number of iterations, and we are clearing the concerns of every step in the workflow via state graph. We also have a retry logic based on the quality of the output in the previous iteration. We have LLM calls to first determine the correct intent of the user, and then we are going into the knowledge base with accurate intent. Based on RAG, we are processing the response via LLM and also validating the output. At every step, we are logging into the state agent about what is happening in that step. We start with an initial state where the first step is user query, and we invoke the graph's state machine. This is a real agent architecture. Let me break down why this is so much better. 1. State management. The agent tracks what it's doing, what it's learned, and where it is in the process. 2. Retries and validation. If the first answer isn't good, it tries again automatically. 3. Observability. Every step is logged in the messages, so you can see exactly what the agent did. 4. Guardrails. We have a max iterations limit, so it doesn't loop forever. This is the difference between a toy and a system. A toy responds once and hopes for the best. A system thinks, validates, and adapts. Step 5. Monitoring and iteration. Alright, final step. Your agent is deployed. You're done, right? Wrong. This is where the real work begins. Production is a learning environment. Every interaction teaches you something. Let me show you how to monitor and improve continuously. This is our agent monitor utility. Using this, we are going to log and monitor the health of our agent. We have a utility to log every interaction, including the query, the response, the timings, and the user feedback. Around the data we ingest, we have utility functions to extract the metrics we are interested in, like the top time taking queries, queries that didn't perform well in terms of user feedback, etc. Using such a monitor in production should be a plug and play. Every interaction that comes into the agent and every response that goes out are the touch points where we need to log into the monitor. In production, I monitor these metrics daily. Average response time, P95 latency, the slowest 5% of requests. User satisfaction rate, retrieval accuracy, token usage and costs. This monitoring setup tells you everything you need to know. Which queries are slow, where users are unhappy, what the agent doesn't know, where to focus your improvement efforts. Here's the key insight. Great agents aren't built once. They're refined continuously based on real data. You ship version 1, watch what happens, fix the biggest problems, and ship version 2. Alright, let's bring it all together. We covered a lot in this video. 1. Master Python fundamentals, fast API, async, pydantic. 2. Build in reliability, logging, and testing from day 1. 3. Implement smart RAG, give your agent real knowledge. 4. Design proper architecture, state management, retries, validation. 5. Monitor and iterate continuous improvement based on real data. Here's what I want you to take away. Most AI agents fail because they're built like toys, not systems. They look impressive in demos, but crumble under real-world pressure. But you don't have to make that mistake. If you follow this roadmap, you'll build agents that handle edge cases gracefully, scale to thousands of users, get better over time, are actually debuggable when things break. These aren't just best practices. This is the difference between a project that gets archived in a demo folder and a system that solves real problems and earns user trust. The code examples I showed you today, they're all based on production systems I've built and maintained. This stuff works. And, alright, that's it for this one. If you found this valuable, drop a like, subscribe for more AI engineering content, and let me know in the comments. What's the biggest challenge you're facing with your AI agent right now? I'll see you in the next one. Now go build something that actually ships.